Welcome back to my program tutorials for the Asuro line following autonomous robot. In previous videos, we covered the first program in the book, which was the program to turn the status LED red. Then we went through the PDF in which I showed you where all of the important code was, which most of that code we'll be using later on. Now, in terms of the first program in the book, this is the one that's on page 54, which is also on my screen here now. One thing I do want to point out is that on the first video, I copy and pasted the code in from the book, and that's always a bad idea. One of the reasons was these speech marks or apostrophes, whatever you call them, they came up as like the incorrect weird one, and when I was trying to flash the Azure, it wasn't working. So I would just recommend typing out code yourself. Also, for these videos, I've actually made a GitHub repo, so you'll be able to go on. I'll put the link to this in the description as well. You'll be able to go on and you could actually download the code as well instead of you having to type it out yourself. Although, again, I do recommend typing it out yourself. So what I've done is I've actually flashed my Azure with this code. I'm not going to go over here how to flash the Asuro, but you can get the instructions from the website that I showed you previously. This Jurgens Homepage. If you follow these instructions here, a link to this will be in the description as well. Follow these instructions and you'll be able to flash your Asuro as well. Okay, so um, I've actually flashed my Asuro with this code here, and you can see now when I turn on the Asuro, the light goes red, it stays red, and that's all that happens. If I was to change this status LED now to green or yellow, the same would happen. So we want to actually improve on this code. The way that we want to improve on this code would be that we want the status LED to go green and then to go red, right? So we want it to flash green, flash red, and just keep flashing between green and red backwards and forwards. It sounds pretty easy, but this is where hopefully you've done the C program tutorials. One thing that I found when I was learning to program in C was that programming on the console, which is the black screen that pops up whenever you run the code, is very different to programming real actual hardware, and you'll see that with the Asuro. So you might be tempted to, for example, say, let's clean this up a bit. So you might be tempted to say, for example, we want the robot, we want the Asuro to flash green, then red, and back again, right? So you could, for example, do this. Let's just copy and paste that. Make this green. So now what you're probably thinking is, okay, so the status LED will go green and then it will go red. Or if you're a bit more clever, you might say, well, hang on a minute, Hamid, that's not actually in a while loop. So let's stick it in a while loop. Okay, fine. While one. Cool. Okay, so we've stuck it in a while loop now, right? So what you think would happen here is that the LED is going to flash green, red, green, red, green, red, and backwards and forwards, right? Here's the video of what actually happens when I flash this code onto my Asuro. So as you can see, pretty much nothing. The Asuro basically the light went orange, which is strange, right? Well, what's actually happening here is that the LED is going green and then the microcontroller is telling it to go red. Now, how long does it take for the microcontroller to send an electrical signal to the LED to say, hey, go green, then go red? I can tell you it's microseconds. And so it's literally switching from green to red, back to green, and back to red. So the only thing that comes up to us when we're looking at the LED is orange. It just looks orange, but that's just because it's switching the colors very, very fast. One way that we will deal with it in this video would be to actually create a counter and use if statements, right? So we'll create a counter which will then the microcontroller will count in ones, and then we'll use conditional if statements to say if the counter's X, then do this. If the counter's Y, do this, right? Let's get coding that now. So what we'll do is we'll leave this init here because remember that always has to stay there. Then what I like to do is I like to actually write out what I'm trying to achieve with my code. So this is a common, right? You should know this. Cool. So what we want is we want a counter that's gonna increment. We want to say if the counter is less than X number, right? Then be green. Otherwise, if let's do otherwise if more than X, then be red, right? Or let's just put LED red. What this is called, if you don't know, this is called pseudocode. So I always do this whenever I'm trying to code. I want to get the logic of what I'm trying to do out of my head onto the page in front of me so then I could just write the code for this as well. Now what we want to do is we want to put this all into a loop. So we want to loop the whole program. And then we also want to if X or if counter, basically we want to reset the counter, right? So we want to say if the counter is, I don't know, let's say 2 times X, right? Reset counter. Reason why we want to do that is because, so we're going to have a counter, let's say it's 0, it's going to count to 10. As long as it's less than 10, the LED on the 0 will be green. Then once it's more than 10, it will go red. Then when it reaches 20, the counter will go back to 0, and this will start again. You got that? And this will just be incrementing every single loop. Cool. All right, so let's code this. So remember, we have to leave the init there because that initializes the microcontroller ports, right? So let's start with a while loop. We've got one here. Let's just remove this one. All right, so we'll make a while loop. If you don't know what while one is, I mean, you should know by now. While one is saying you should know what while loop is, but while one is obviously saying that as long as the number one is one, then do this. And obviously, because the number one is always going to be the number one, and that is true, then this code is going to run continuously. So we want to have a counter. Let's declare a counter up here. Let's do int counter is equal to 0. All right. Actually, what I'm going to do is I'll explain why afterwards. I'll make that a long. Cool. So let's increment the counter on every iteration of the loop. Right. So every time it goes around the while loop, the counter increments by 1. Then we want to say if the counter is less than, we'll do 10 for now. Let's do 5. If the counter is less than 5, then status LED is green. Cool. Otherwise, so else if the counter is greater than 5, right? Then we want to make the status LED red. Cool. So that's that bit. These two bits here. We're incrementing a counter. If the counter less than X, LED green. If it's more than X, so X here being 5, then LED red. Then we want to put the last conditional, which is that if the counter's like 10, 2X. We'll put it inside this statement here. If counter is greater than 10, then we'll reset. Sorry, time for reset counter. Counter is equal to 0. Just want to make sure I've got the logic right. So if the counter is greater than 5, yep. The reason why we want this if statement inside this else if, right? So we want this if statement inside the else if. If we had it outside, it wouldn't be getting executed. So if counter is greater than 10, so from 5 to 10, or from 6 to 10, the LED will be red. Then after that, it'll go back to being 0. Now, return 0 is when we end the program. Yep, and that's it. Yeah, so that's our program complete. So a few things in terms of long. Hopefully you know what long is, the difference between a long, a float, a double, etc. If you don't, then probably your best resource would be Stack Overflow, which is where I learn everything. They go over the different integer types, 16 bits, 8 bits, 32 bits, etc. Now here's a funny question. If you just try to run this code now, the same problem that I mentioned beforehand with the microcontroller switching the color of the LED rapid, the if you think about it, right, for a computer or a microcontroller being a mini computer. So for a computer, how long does it take it to count to 5? If you think about it, how long would a computer take to count to 5? Does a computer count in seconds? The answer is it gets to 5 very quickly. So what's going to happen is you're not going to see anything. If you run this code on your Zero now, I mean, what are we going to see? We're going to see if it's so it'll go green, then it'll just quickly go red. I'm going to assume that it's probably going to be like an orange color again. So what we need to do is if we times everything by 1,000, even this, a microcontroller is going to be able to count to 5,000 very, very quickly. Trust me. However, we will still see something. We'll still see more of a flashing going on with these figures. So, try it, run this. What I'll do is I'll show you now what happens in my Zero when I flash it with this code. So here's the code with me flashing it on my Zero, and here's how the Zero reacts. As you can see, it flashes very quickly because the microcontroller can count to 10,000 very, very quickly. So even if we increase the counter values, it won't help too much. This is, I'd say, an easier to understand way of looking at it. And this is the way that you'd do it if you was programming just on a console by yourself and you was dealing with human input, etc. However, when you're dealing with microcontrollers and robots, it's all very different. What we want is the microcontroller actually has a clock. We can use that clock to get the microcontroller to do things in terms of actual seconds or microseconds. So what we'll do is in the next video, we'll improve on this code from here. And what we'll do is we'll start using the microcontroller's clock to get the LED, to get the microcontroller to sleep. And that way we'll be able to actually, or by sleep I mean pause, but it's referred to as sleeping. We'll actually be able to get the microcontroller to change the LED to green and then pause and wait a few seconds and then change it to red and wait a few seconds and we'll get it to do that in a loop. And you'll find that that will be much easier than this, but I just wanted to make sure you understood while loops, if statements, how to use them, counters. You're going to want to use all of this when you're coding your Zero. For my actual final For my final Zero project, I actually used the counter as it was going around the track. I created an algorithm using a counter to get the Azura to do something every X amount of times. That really, really helped my Azura for my final project. So, yeah, I hope you benefited from this. If you did, please leave a like. Feel free to ask any questions in the comments. Thanks for watching, and I'll see you in the next one. Peace.